In this video, I'll be talking about simple pendulum motion. So there's really only one formula that you need to know for simple pendulum motion. And that formula is for the angular frequency. So the angular frequency is calculated by gravity divided by the length of your pendulum's rope. So let's say there's a rope attached to a nail on the wall. And your pendulum was a gold coin, let's say. Okay? So basically, this rope right here, the length of it more specifically, is L. And G is just gravity. That's very simple. It's the only formula you need to know, besides the other formulas that you need to know for motion, but I've covered those in other videos. Link will be down in the description for those if you still need some help. But let's start and do some problems related to simple pendulum motion. Now this problem is a simple one. All it does is combine the formulas for angular frequency. So this is a pendulum, and we're always going to be doing math with a simple pendulum. And the formula for the angular frequency is square root of gravity divided by length. And we're trying to solve for the length, so that tells us something about isolating this length value. But we don't have angular frequency this problem, and we only have the period. So we can combine the formula for the period of your angular frequency and set these two equal to each other. So the square root of gravity divided by length is equal to 2 pi over t. And so if we isolate the length, since that's what we're solving for, we can square both sides. So g square root cancels if you square both sides. And you get 2 pi over t squared. And then you can isolate your length again by multiplying length onto the right and then dividing this entire equation. So what I mean is multiply this by length. And then you get g is equal to 2 pi over t times L, and then divide 2 pi over t squared on both sides. So you get g divided by 2 pi over t squared, and that's equal to your length. So you just need to plug in the numbers. G is 9.8, which is our gravity of Earth. 2 pi divided by your period, which is 0.5 seconds. And you square this. Just evaluate this in a calculator, and you should get 0.06621 meters. But if you want this in centimeters, it's just 6.21 centimeters. Another simple question. There really isn't much to say about simple pendulums. They literally are the same thing as any oscillating motion, but you just calculate the angular frequency different. So for this problem, how long does it take for a child on a swing to complete one swing if her center of gravity is 4 meters below the pivot? So we can calculate the angular frequency here. Angular frequency is gravity divided by the length of your rope, or the distance from the axis of rotation or pivot. So right now, the child's center of gravity is 4 meters below. That means that the length of this rope is, oh hell nah, okay, that did not look right. The length of the rope right here is 4 meters. So that means L is equal to 4 meters. So take the square root of 9.8 divided by 4. You get 1.57 radians per second. That's the unit for angular frequency, and you want to calculate the period, or the time it takes to complete one full swing. So remember, angular frequency is also equal to pi over period. You can isolate period here to get 2 pi divided by angular frequency is equal to t. That means you can divide 2 pi by 1.57, or your calculated angular frequency. And that should be equal to just 4 in seconds. So this will be the last problem. My house ran out of milk, and I ate cereal without the milk, and it tasted horrible. So don't do that. But if a cable on a pendulum that is 42 meters long held up a 1,000-ton block of steel, so this is an extremely strong cable. Not relevant to the problem, I just wanted to mention that. Holds up a 1,000 tons block of steel. Find the largest possible acceleration in the steel block. So how do you find the largest possible acceleration? Well, in order to find the largest possible acceleration, let's write down the acceleration formula in simple harmonic motion or oscillating motion. Negative a omega squared times the cosine of omega t plus your phase shift. So this is the formula for acceleration. Now, the maximum value of cosine is either -1 or 1. Anything between -1 or 1 just decreases the magnitude of your beginning term here. So all we need to do is set cosine equal to -1 or 1. If we do so, their maximum acceleration will be equal to amplitude times omega squared. Now the negative goes away because the negative doesn't matter. We only worry about the magnitude of your acceleration. So the negative just indicates direction, but that doesn't change the magnitude of your acceleration. So we just need it in positive format. So amplitude times omega squared. Well, omega is your angular frequency here, and we're given the amplitude is 1.5. So let's find the angular frequency. That's what we need to find out. So we can calculate the angular frequency of simple pendulum motion using gravity divided by length. Well, we have gravity and we have the length of the pendulum. So all we need to do is set up that. 9.8 divided by 42 square rooted is equal to 0.483 radians per second. It's quite slow. Now that's because the cable is very long. So we have the angular frequency and we have the amplitude. So all we need to do is plug all that in. So your maximum acceleration is 1.5 times 0.483 squared. And in total, that is equal to 0.35 meters per second squared, as that's the unit for acceleration. As always, I need to mention OpenStax. It's a free online textbook. I get my problems from there. Link will be down in the description. But if you found this video helpful, consider subscribing. Thanks for watching.